So I've posed you a bunch of questions on collinearity and looking at points which are collinear and the properties of them. What I'm going to do in this is I'm going to look at these questions and I'm going to work through the solutions, show you how you should approach them. Quick refresher for you though as to what those questions were. First one, are the following points collinear? Justify your answer with working. So I gave you 3 sets of points in 3 different questions, and I wanted you to prove if those points were collinear and show the working to do so. And then the second question was, if P is -6, -5, Q is 0A, and R is 12, 8, and they're collinear points, what is the value of A? How would we approach that? So let's have a crack at these ones then. So the first one, I've got 3 points, A, B, and C there. I want to know if they're collinear or not. Now remember, collinear points, if I take any pair of points from the 3, so if I take the gradient of AB, the gradient of AC, and the gradient of BC, what you find is the gradients are all equal. So we need to prove it matches for any pair of them. The key thing is they have to have a common point between them. So it could be the gradient of AB, AC, it could be the gradient of AC, BC, or it could be the gradient of AB, BC. Doesn't matter, there just has to be a common point between them. That has to be the case. So for this one, let's imagine I start with the gradient of AB. So gradient of AB, using these 2 points here, is -3 take away -5 over 0 take away -4. So -3 take away -5 is -3 plus 5, which is 2, and then 0 take away -4 is 4, so that gives me a half. If I then went to say, right, let's look at the gradient of BC, let's imagine that one, so these 2 points here, that would be 1 take away -3 over 8 take away 0. So 1 minus -3, minus becomes a plus, 1 plus 3, that's 4 over 8, which is a half. So I could say at this point, great, that would work. Let's just prove it though. So imagine I did the gradient of AC. In this case, I would do 1 take away -5 over 8 take away -4. 1 minus -5, minus again becomes a plus, so that would be 6. Same with the bottom, that would become 12. So it's a half. So all I've shown with this one is I've got the same gradient for all 3 of them. You don't have to do it for all 3 each time, you just have to pick a pair again, it's a common point. So I could say, so the gradient of AB equals the gradient of BC, and B is a common point. You have to make sure you've got that there. B is a common point. Therefore, A, B, and C are collinear. You have to explain it at the end. You have to tell them why they're collinear. So it has to involve matching gradients and a common point. Second one here. So let's do this. So let's imagine I look first at the gradient of D to E. Let's start with that one. So I get 0 take away 1 over -1 take away -2. So I get -1 over -1 plus 2, which is 1. So I get a gradient of -1. Then again, you could pick any pair of points at this point, as long as D or E is a common point. So let's have a look at the gradient of D to F. -8 take away 1 over 7 take away -2. -8 take away 1 gives me -9. 7 minus -2 gives me +9. So it's -1. So there you go. I've got the same gradient for the pair of them. I've got a common point. It's the same. So what I can then say is therefore the gradient of D to E equals the gradient of D to F. And D is a common point. Therefore D, E, and F are collinear. Remember that evaluation at the end. You have to state what it means. Big deal, you've done a couple of gradient things and got a same number. Whoop-de-doo. Explain it to them. Tell them what it is and include these statements. Include it about the gradients being equal. Include about the common point. Make sure you state they're collinear. Okay, last one then, in this sort of question. Imagine I've got these 3 points, G, H, and I want to show, are these 3 collinear? Well, let's start from the beginning. So we start with the gradient of G to H. So gradient of G to H, 3 take away -6 over -1 take away 2. So 3 minus minus 6 is 3 plus 6, which is 9. Negative 1 take away 2 is negative 3. So I get a gradient of negative 3. Let's imagine then I do the gradient from G to I. Well, the gradient from G to I is 8 take away negative 6 over negative 3 take away 2. 8 minus minus 6, 8 plus 6, that's 14. Negative 3 take away 2 over negative 5. Well, in that case, that's negative 2 4/5. Well, hold on a second, they don't match. Maybe I've just used the wrong point. Let's do the gradient from H to I. I'm sure that'll work. Gradient from H to I, 8 take away 3 over negative 3 take away negative 1. 8 minus 3 is 5. Negative 3 take away negative 1 is negative 3 plus 1 over negative 2. So that's negative 5 over 2 or negative 2.5. Well, wait a minute, none of these gradients match though. I've got common points between them, none of them match. What I can then say is, therefore, the points are not collinear. They're not collinear. We don't have any matching pairs of gradients with a common point between them. So they're not collinear. The three of them won't be on the same plot. So you probably end up getting, if you've got the 3 points here, one where one does that, and the other one does that between them. So it'll look wonky like that. It won't be 3 common points. Last question I'd ask you, if the 3 points here, P, Q and R, are collinear, what is the value of A? Well, we know that for it to be collinear, the gradient of P to Q will equal the gradient of Q to R, or the gradient of P to R. So what we have to do is use this property to set up an equation and solve it for A. So let's imagine I do the gradient of P to Q. So in this case, I'd get A take away negative 5 over 0 minus minus 6. So in this case, I'd have A plus 5 over 6. And then I could pick any of these two that I want. I don't want A's on both sides. That would just give me a bit more algebra than I'd really want to have to worry about. So I'm going to go with this one here, the gradient from P to R. So gradient from P to R equals 8 take away negative 5 over 12 minus minus 6. So in this case, that would be 8 minus minus 5, so that's 13, over 12 take away negative 6, that would be 18. What I'm then able to do is say, right, so A plus 5 over 6 equals 13 over 18. So there's a variety of ways to solve this. So you could imagine if I times this side here by 3 over 3, what that's going to do is turn the bottom into an 18 and the top into 3 bracket A plus 5. So I'd have 3 bracket A plus 5 over 18 equals 13 over 18. What I'm then able to say is, well, the tops must match each other in this case for the two fractions to be equal. So I could say, fine, 3 bracket A plus 5 equals 13. And then it's just a case of solving it. Multiply the bracket and you get 3A plus 15 equals 13. 3A equals 13, take away 15 is negative 2. So A is negative 2/3. So we know what value of A would give us the 3 points to be collinear if A was equal to negative 2/3. Now, we never said it always has to be whole number values from when we're plotting points or using coordinates. So that works there. So there you go. There's those 3 questions worked out for you. Have a crack at them. See you in class.